Starting now. So welcome to the community meeting, 25th of May. Agenda for today is an update from the project around the roadmap and what we've been doing, and then we've got 3 demos. You guys are going to have about 15 minutes each. First update is about the CNCF working group. Cloud Native Computing Foundation has a working group that's looking into serverless. The last call that I was on, I believe John and Charlie Pitkin joined as well. We had 37 people from different companies and clouds there represented. One of the outputs from sort of late last year was this white paper that said what the industry thinks serverless and FaaS is, gave some use cases as well. The landscape that some of you would have seen already for serverless was another one of those outputs together with Redpoint VC company. And the latest thing that's happening is this work around CloudEvents. Azure are the first cloud to actually implement CloudEvents for their event grid. And what CloudEvents is aiming to do is to make it easy to consume different resources. So if there's a trigger when you push code into Git, hosted Git, or there's some kind of Kafka stream, service bus, and S3 bucket, right now there's different ways of getting at that data for every cloud provider. And so this is trying to harmonize that. We can support it already, and John's going to show you that. Now, there are some very similar projects to ours in the community. And so I put this together for one of my presentations recently. And what I want to do is just to kind of give you something that you can use when you talk about the project to help you understand, what are the benefits of using OpenFaaS? What makes it stand out? Well, it's serverless on your terms. You can literally run any code you want, and even performantly too. Run it anywhere, and it's exactly the same on your laptop as in the cloud. Anywhere where we have Docker or Kubernetes. You can run at any scale horizontally by adding more pods in your static capacity, but you can actually bring on more cloud computers as well if you want, very easily. And we really focus on ease of use. So some of you have already contributed to the CLI and the UI components. You would have seen experience there. We've got some open issues at the moment and some areas to help us with that. But these are really the things that make up OpenFaaS. So where you're using a fully hosted cloud service and you have hard limits, maybe a 60 megabyte image for your function, maybe a 5-minute timeout, right? With OpenFaaS, you get to decide the limits, but with that power, there's some responsibility as well. Those are the key things to highlight. Want to give you an update on the core group members. So we brought Lucas into the core contributors group. Thank you, Lucas, for everything that you've been doing in the project. We also have Eric, who spoke at I believe it was a Kubernetes meetup this week on Wednesday, had really good feedback about that. Richard Gee, who came and supported me at a workshop in Peterborough, helps us with the CLI. Obviously myself, and then Stefan Proden at Weaveworks, who's been helping us build out our Kubernetes integrations and doing a great job at that. These are some of the things that the core contributors we all met together came up with for what we think we should expect of each other when we're carrying out that role and we're in that group. Feel free to take a screenshot. This is going to be condensed down and put into the contribution guide, so it's clear what it means when you want to step up and become part of that group. So some of you will have heard me talking about OpenFaaS Cloud. This is the idea that you can work on your laptop, push to Git, and everything else is taken care of you as far as your functions are concerned. So you build your function in the normal way of the CLI, you push it to Git, and you actually get an endpoint out the other end. Now the name may be misleading because it sounds like it has to be hosted by us or someone else. Actually, you can run OpenFaaS Cloud wherever you want because it's made up of a series of small functions. So I have a GitHub repo I've been using for testing. I'll just show you it now. And in the root, there's our normal YAML file. And in this instance, it's called stack.yaml. We see two functions there. And what this enables me to do is just edit the code. So right now it was saying hello Docker London, hello OpenFaaS community, and we could click commit there. There's actually a web page that goes with this that shows you what functions you have when they were accessed, and you get a link for them. So each of these come under your own account name for the HTTPS URL. We see the code there. I can now hit commit. So you could use a pull request as well. There's actually a message comes into Slack. And then within a few seconds, this page will update. And that has already been deployed. Right? So our new endpoint is deployed. It's ready to go. If we look at our list of commits, we actually see a tick because we've got an integration with GitHub. And this is showing that your function is now ready to use. Refresh it, and we've got our new message. That's OpenFaaS Cloud. There are some restrictions with it, but it's mainly to make it a safe place to play. So if you're interested in working on this or helping with some of the overview pages, everything's split down into very small functions, so it's easy to test. And one of the bits of feedback I got last night was somebody came up and they said, our team isn't technical, but when you showed us OpenFaaS Cloud, we could see how they could potentially use functions without knowing Docker and Kubernetes deeply. I think that's some really good feedback. So if you want to know more, there's a public trial that I'm running, and you can get access and start running your own functions here too. One of the things that we're looking at doing is enabling you to have your own secrets. So if you need an API key, you can do that securely too. So that's OpenFaaS Cloud. Got two more slides and I'll hand it over to Ed. The next thing I want to talk about is operating OpenFaaS in a robust way. So you may be thinking about how would I deploy this in production? How can I make sure that everything's working right? The first thing I'd suggest is to use Kubernetes. If you have the option of doing it, use a managed Kubernetes service because it will be easier. And you get things for free like a registry and persistent volumes. But if you do want to run it on your laptop or on a box at home, you can do it. You're just going to have to maybe deploy your own registry. HTTPS, definitely enable this. It's not hard to do. You can use something like Caddy or provision your certificates automatically. Basic authentication is now enabled in the gateway. So even if you forget to set up your proxy properly, if you enable this on your API gateway, people won't be able to deploy functions. Which I think is a step forward. You should have HA everywhere, which means high availability, more than one replica of your gateway, more than one replica of everything else, including your functions. Okay. Network policy is something that Stefan has been documenting for us in one of his blog posts. And this will effectively mean that your functions can be separated from each other and also separated from the administrative services. The last thing that you need is a CI/CD workflow. And as I said, you could deploy OpenFaaS Cloud for that, or you could use what you already have. Okay. And when it comes to operating this on a daily basis, day two, you want some kind of monitoring for it. So there's Prometheus Metrics built in, and this is a screenshot of what that would look like in Grafana, a free tool. And if you speak to Stefan, he works on a project called Weave Cloud, which is a really neat way of just extracting all of this information out so you don't have to worry about it. So that's the update. In terms of the roadmap, I'm really looking to keep building the team out within the community. So we have one more person that's joined the core contributors group. We've got several people that have started contributing code recently, like Kieran. And then we're doubling down on OpenFaaS Cloud. So this is something I think that's going to help OpenFaaS make sense to people. we have our early adopters, we have these use cases, but if you're not confident with Kubernetes, how do you then make that available to your whole team? Maybe this is the way. Going to continue integrating with CloudEvents, as you'll see from John. And I'm doing some work. I've proven this out with a proof of concept. We can scale to 0 replicas and back up again. So that needs some more testing before we actually integrate it. But I think that could make sense for people who have got a large team and then maybe not using their cluster 100%. Stefan has a Kubernetes operator that he's been working on with us, and that has ported the code from FaaSnetes over to Kubernetes so that you can do kubectl, get function, and that kind of stuff. And then there is some interest around creating a JavaScript CLI for the serverless project. So if you're interested in any of these points in particular, or you want to try OpenFaaS Cloud, just reach out in Slack, OpenFaaS, or contributors. So have we got any questions before we move over to Ed's demo? Hi, Edith. Okay, so no questions at the moment. I'm going to stop sharing. Over to Ed.
Hi, everyone. Is that sharing okay, Alex? Yeah.
Yeah, looks good.
Awesome. Yeah, so I'm very new to OpenFaaS. I attended Alex's workshop in Peterborough a couple of weeks ago. So I don't know much about the project, so I'm certainly not an expert. So yeah, bear that in mind when you see this demo. But I wanted to play around and see if I could get OpenFaaS to work with AWS, as we're using Lambdas at the moment and we're not very happy with the overhead of the maintenance and how you deploy them, because we only use them a little bit, but they cause quite a big overhead. So I was quite interested in the OpenFaaS thing. So what we're looking at here is a couple of ECS clusters on my Amazon account, and I've created an OpenFaaS one. And inside here, you can see there's 2 functions running. And this one was created and deployed using the OpenFaaS CLI. And what I want to quickly do in this demo is create a new function, deploy it, and invoke it, all using the OpenFaaS CLI. So hopefully this will just go smoothly. So I'm just going to create the new Go template and quickly build it. Ooh, that didn't work. Yeah, that was good. And let's push that up. So at this point, I should be able to, because I've deployed it, I should be able to list it using that list command. And you can see here that it's spun up the, or it's listing that the Hello Girl World 2 function has been deployed, but it's not quite yet running because I've got a 0 replica count. So I'm using Amazon's Fargate, which is a way to run containers without operating any servers. It seems to, and I'm not an expert with Fargate, we've used sort of classic ECS at work, which is the tool that I'm familiar with. But it seems that it takes a while for these to spin up. But you can see here we've now got the Hello World 2 app, and it's running its container. And if we go over to this task view, you can see the container's running, and it looks like it's healthy. So if I go and list that again, you can see that it now has got a replica count of 1. So the next thing is to go ahead and invoke that function. And yeah, there you go. You can see that that's running the OpenFaaS stuff. So that's sort of as far as I got in a couple of train journeys on the way from Peterborough to London, just to see if it was at all possible for us at work to use OpenFaaS. So I think the results of my experiment, it does seem that it's going to be fairly viable to do this integration with with Amazon. I think I've made a lot of assumptions with this minimum kind of implementation, and there is still a lot of work to be done to make it like a full provider in the same way that the sort of the Nomad one and the Kubernetes one is. But it does seem like there's a good match between the two systems. So there was no real impedance mismatch when I was trying to do the integration. It all seemed to go quite smoothly.
This looks great, Ed. I think that AWS has such a big market share. There must be a lot of people who are looking for an alternative, and this could shape up to be that for them.
Yeah, I mean, we certainly are. We're a very small team, and we don't really have the time to look at moving to Kubernetes or even the managed one. It's just not something that we've got time to do. So, but we're quite happy with ECS. We realize it's not the best container scheduler out there, and that Kubernetes is better, but we've got other things to worry about at the moment. So this is going to be great for us, I think, until we move on to Kubernetes, which could be in 12 months' time.
Is any of this code on GitHub at the moment, if we want to have a look at it?
It's on GitHub as a private repo at the moment. I just wanted to get something that was sort of at least a minimum viable product before I made it a public repo. And I wanted to put some good tests around it as well. But I mean, I'm happy to open it up, but it's a bit gnarly at the moment.
Yeah. Okay. Anything you want to tell us about the implementation?
No, it was quite straightforward, really. I used the Amazon Go SDK for doing all the interaction between the Amazon services, and I looked at the FaaS Kubernetes provider implementation to see sort of, how the system from the FaaS point of view interacted. There's lots of questions that I have about my own implementation that I will probably be asking knowledgeable FaaS people to help me answer the questions. So I made a whole list of those. So I'll probably be asking those in the Slack channel over the coming weeks.
Great. I really like this. Anybody have any questions for Ed about the ECS or Fargate backend?
So Ed, this is a similar service to Azure ACI, right?
Can you describe to me Azure ACI?
It's container instances. It's deploy a container without worrying about any kind of orchestrator deployment.
Yes, that sounds like it's the same thing then, yeah.
I'm just thinking maybe we could port the code to that system as well, and then kind of get two cloud providers for the price of one. I'll look into it.
Yeah, I thought the same thing. I thought Azure's probably got a similar service to Fargate. So you probably wouldn't be able to reuse any of the code because it's all very AWS specific, but you could certainly look at, it's probably an easy one, easier to copy than the Kubernetes sample because it's, I guess you'll have more similar constructs that you need to match up.
So I think one of the problems we had with ACI was that they didn't support private networking between the services. Do you know if that's something you can do with Fargate?
Yeah, so with the Amazon implementation has quite extensive networking. So you can connect it to your own private VPC and you can lock down a function with security groups, or a container, sorry, in AWS terms, with a security group that's connected to your private VPC. So, you can control it as much as you want. So by default, when it's connected to your VPC, there would be no external access to that container.
What about so what have we deployed? Hello Go World 2. How's the gateway accessing that function? Does the Hello Go World 2 have a private IP and the gateway talks to it over that?
Yeah, so for this, like I said, this was a minimum viable product, so it's not secure. You wouldn't use this in production. But what I did is when I deploy the function, I attach a public ENI, so Elastic Network Interface. So it has a public IP that's got no authentication on it. And the gateway is running locally on my machine, talking to the container running in AWS.
And that's for your provider?
Yeah. Does that make sense?
And then how does your provider talk to the function?
So it uses this proxy. That code is actually a direct copy from the Kubernetes one. The only thing that I had to do was, when you look up the host name, at the moment it goes off to Amazon and finds that network interface and gets the public IP address.
Okay.
And then it calls it over the internet. So it's calling it from my machine. The provider's calling it from, so the provider's running on my machine, the gateway's running on my machine, and then the provider from my machine is calling over the internet to that container using the public IP address.
Okay.
I guess in production, you'd run all of this in the VPC privately.
Yeah.
And we'd have a way of sort of saying from here, like, don't use the public IP address, we're running all privately, so you call it over a private network. So
yeah, and then the gateway, maybe the gateway would be behind an ELB.
Yeah.
Cool. Any other questions before we go over to the next demo?
I could perhaps draw a diagram of this, how I've got it running locally to make it clearer.
I have a question about secrets. How do you manage secrets in ECS?
Can you say what your name is as well when you ask?
My name is Dmitry.
Hi, yeah. So Alex was asking about this. I've not done the secrets yet, because I guess that would be a step 2 type thing. Amazon does have its own Amazon specific way of doing secrets that I think it's attached to the KMS service. We don't use that at work. We use HashiCorp Vault. So I wasn't super interested to do an integration with KMS, but I guess that would be the sort of the Amazon way of doing it. I don't know what you guys at OpenFaaS has, what you guys plan to do, because you use Docker.
Yeah, Docker Swarm secrets and Kubernetes secrets, and I don't know if Nick got around to secrets in the Nomad, but we could talk about that offline. This is a fantastic start. I'm really excited about this. I could see it being really, really useful, even without many changes from where it is now. So thank you, Ed. Really appreciate this. This is being recorded, so I'll upload it later if you want to share it with anyone. John, are you ready to switch over? McCabe?
Yeah, give me 2 seconds.
So the next 15 minutes, John will present, and then quarter 2, switch over to Stefan. Out of interest, has anybody been taking any notes at the moment? No.
Okay, can you see my screen there?
Yeah, we can see it.
Yeah, so as Alex pointed out, the CloudEvents is kind of a new spec that's being worked on under the auspices of the serverless work group at CNCF. It originated mainly from sort of the serverless guys, and what it's trying to do is sort of add the ability to treat events, sort of handle events with one common format. Because if you're consuming stuff from Azure, AWS, Google, what have you, they all have their own formats, they all have their own structures, and it means you have to implement specifically for every single cloud provider, which kind of makes sort of implementing functions more sort of convoluted than it should be. You should just be able to take a sort of a common format for events, which is what this is trying to do. So it's CloudEvents.io webpage. If you go there, you'll find out a bit more information. And what's being worked on at the minute is the actual spec. So there was a 0.1 version of the spec released, I think just in time for KubeCon. and that includes like a very, very, very early initial sort of definition of what a cloud event actually is. So if we go to, let me see. So JSON event format, you can see that this is basically the format that they've kind of set for a cloud event. At the moment, it's very, very much a wrapper. The content of the event that you get, so say if specific to S, creating an entry in S3 or a message coming in on a queue or what have you, you're kind of left on your own to do the decoding. It's purely a sort of an envelope really at this point. And at the moment, one of the first sort of cloud providers to implement support for this has been Azure, where they've implemented the ability to create a notification in Event Grid that outputs in CloudEvents format. They actually don't adhere to the format because they don't actually provide a content type, but it was easy enough to kind of work around that. So I'll just show you a quick example of what that might look like. So if you look at, can you see it? If you can, right. So if you can look at that, the command I've got here. So this is using the Azure command line tool to create an event subscription in Event Grid. I've got some variables set up. What this is looking at is sort of storage container. So it's basically like an S3 bucket called CBH-FaaS event. I put this demo together for my talk at Serverless Copenhagen last week. So it all got kind of thrown together the night before. So it was a bit last minute. Setting the endpoint to an OpenFaaS cloud deployed instance of the function. So Alex actually was able to help out here by adding some very initial support for setting secrets there in order to get that pushed up. And where cloud events actually, everything up to that point is just like setting up a normal event subscription in Event Grid. What's new is the ability to set this event delivery schema and specifically to support this cloud event v01 schema, which is what you see implemented over here. So what I've got is a very simple function, this cloud event function. And what it does is it monitors events from container storage. The subscription is set up in Event Grid. So if I drop an image into a storage container in Azure, that will result in this like Microsoft storage blob created event. But when it hits Event Grid, because I've set the schema to cloud event, what it actually sends me is a cloud event with that event sort of wrapped in it currently. So that comes across, hits the function, and what I'm doing in the handler is I'm handling the event as normal. Because Azure sort of performs like an initial validation step, the first thing I have to do in the function, this could be carried out offline if you wanted to sort of validate your endpoint offline. There's tweaks to the workflow here, but what this does is if it receives an Azure validation event, it will actually respond appropriately. So you have two options there. An Azure validation event comes in with this subscription validation data, which is a code, this validation code, which if you just respond to the event with the code in the body, with this validation response, if you just put the code into the validation response, Event Grid treats the sort of endpoint that it's going to be sending these events to as valid and will continue to send them. If you don't respond appropriately, it won't actually continue. It won't send you any of the content. The alternative is there's this validation URL. So what you could potentially do is just echo that out in the logs or trigger another function that sends that to Slack or sends that to wherever to tell you to go to that URL to validate, by going to a browser and saying, yes, this subscription is valid. So there's a lot of options around that. Potentially that could be pushed into some sort of sidecar for sort of managing more broadly with Azure. So it handles this as your validation event. So once the first message you get will be a validation. When you actually add the subscription here, it will send a validation event. So this responds, your endpoint's now validated. The cloud event, all we actually had to do here was just attempt to unmarshal to the cloud event. So if we receive a cloud event, we just unmarshal it to this cloud event struct that I've set up, which is the v0.1. And that means that I've now got a cloud event here. Now, at the moment, as I said, cloud events seem to be just an envelope. They're just a wrapper for whatever sort of cloud specific data. I spoke briefly to Austin Collins at the conference, and I think the intention is that it sounds like what they want to do is have some sort of common core events that can be that cloud events will sort of map things to. So, for example, creating a blob in some sort of storage bucket, whether it's S3 or Azure or Google or what have you, there are certain fundamental common things to that, such as, what's it called? How can I get at it? Things like that. So you could potentially see that getting absorbed in at some point in the future, where you don't have to do this step where you have to actually try to convert it to the specific event that you've received. So in this case, I've got the cloud event. I now need to sort of convert the body, the data that I've got in this cloud event. So I've got in this, it comes in as a map. So I need to convert that into the actual sort of storage blob event from Microsoft. Go ahead and do that. And then just to sort of show that we can do something with it, I've got a sort of a send message function which sends the cloud event and the URL that's contained in it to Slack. And that's it. So I can show you that working. So if I so what I'm going to do here is I'm going to upload a file. So I have a file sample.gif in this directory. So I'm going to upload it to this storage container. So if I hit that, So what's happened here is that's been uploaded to the storage container. That's resulted in the event triggering, being sent to Event Grid. Event Grid then sees that there's a subscription and that the subscription format needs to be in this cloud event format. That gets sent to the OpenFaaS function, and then the function is able to kind of, first of all, pull out that it's a cloud event, and then pull out the content within that to be able to sort of pull out the URL here. So here you can see the actual raw cloud event that comes in. So you've got your event type, which is this Microsoft storage blob created. So that's how, here I'm actually sort of switching on the event type to know how to handle the data. They're not sending the event type version at the minute. Cloud events version, obviously it's the 0.1 spec. Source is where this has actually come from. So this is a pointer to the subscription in Event Grid, a unique ID, timestamp. I'm not sure, actually, Eric, you might know who, you might be able to contact somebody in the Azure team, but they do not seem to set the content type, which is, I think, required. So that doesn't actually get sent. It's present here, but that's in the data payload.
So you should contact the guy called Clemens.
Right, yeah.
You're looking at the spec and the issues on the Cloud Events repo. You could raise an issue there, or you could just comment.
Yeah, I didn't want to raise it
on the Slack, the CNCF Slack.
Yeah, I didn't want to raise it publicly because it's specific to their implementation. So yeah, so this is the cloud event that we received, and here I've pulled out the image, so that's getting pulled down from the bucket, and that is basically cloud events 0.1. There's a lot of work to go on here. The potential is huge. Whether all cloud providers adopt it remains to be seen. it comes down to whether sort of they actually want to sort of make it easy to interwork between cloud vendors. Where you could see this being useful would be, right, say for example, you liked AWS for, say you liked some sort of some services in AWS, you liked maybe the machine learning kind of services that you could get in Google, you were maybe using other pieces out of Microsoft, and you wanted some way of chaining events together from all of those sources. At the minute, you have to hard code to all of them, but what you could see with CloudEvents is that you have a common sort of message, exchange format for events sort of between those, which then lets you do sort of very nice things with chaining and passing data around. But yeah.
Is there anything else you want to show us, or should we take some questions before switching over to Stefan?
Yeah, I can show you. The other demo that I put together is, let me just open it here. I did a second demo for this. I tweeted about it a while ago, I think sort of, so
while we're watching this, Stefan, do you want to get your demo ready to go?
This is super cool stuff with the CloudEvents, so I think that's a good move for the CNCF. It'll be good for all of us if it's adopted.
So let me see. I can't find the local workspace, but this is public at the minute. So basically, what I did was I put together, this was for serverless CPH as well. Because that conference was coming off the back of microservices conference, and a lot of people were kind of building services for kind of web platforms and so on. I wanted to show something that was kind of, like a small web app. So you can go to this URL here. You can open it up. If you have an Android phone, it works. Doesn't work in Apple because of the way I'm sort of rendering the camera directly to the canvas. But what you can do is you can just open it up on your phone or your laptop, and if you click on the screen, what that does is that captures the image and sends it to a kind of a slightly tweaked variant of the inception function, where it's been changed to accept post data. So it posts the data to that and gets back the classification, and obviously figures out that I'm not a hot dog. But if I were to show it a hot dog, it can pick up that it's a hot dog. And obviously you can tweak that to sort of pick whatever gets classified. So what's nice about this is it's just two functions. It's because the web page itself, I'd originally asked a friend who is like a React kind of specialist to put together a web app, and it was huge and it didn't have the live video display or anything like that. So I just ended up hacking together some really, really janky JavaScript myself. So it's literally just, it's one stat, like that's it. It's like 250 lines.
Do you want any questions?
Yeah.
We'll switch over.
Yeah, go ahead.
Yeah, I had one question about the where you validate the event registration. That's presumably specific to each cloud vendor, is it? So
yeah, so there is actually what they're talking. It was actually discussed yesterday where they're trying to kind of standardize on sort of that kind of validation authentication step with webhooks. So that is something that will fall under it's looking increasingly like that's something that will fall under the CloudEvents spec. So what you see here is completely Azure specific, but what you may very well will likely see in the coming weeks and months is that there'll be sort of an actual CNCF stipulated mechanism for this. Because like at the minute, the two things that are kind of cloud specific are obviously this validation step. Most clouds will.
Like the subscription, right?
Yeah, well,
that looks like it's being fleshed out within the working group, and they're looking like they want to use OAuth strictly, which may mean that you have to become an OAuth provider, or validator in order to accept these in the future. This is just a normal webhook at the moment.
Yeah. So just for context, like there was an initial kind of demo given at KubeCon where a couple of the platforms had sort of hooked up with the guys at Serverless and demonstrated their platforms handling CloudEvents, but I think they all ended up, using some form of gateway. Is that correct, Alex?
So basically, they just got invoked with HTTP because projects like I heard OpenWhisk couldn't handle the new media type. So the thing that I like is that we could do this in the function without changing the API gateway. I think that's a good step. But if they do force OAuth validation on every request, that may mean having to add other things into the stack. So having a presence at the meetings and feeding back into that spec is important. So thanks for that, John. We've run out of time now, and it's going to be over to Stefan. And if you finish within your 15 minutes, I hope Lucas can tell us a bit about what we're doing with secrets as well, unless you get to. So just share when you're ready. Okay. Right, I can see that.
Okay. Okay, so in the last week, I've been working on building a OpenFaaS Kubernetes cluster, OpenFaaS Kubernetes cluster definition inside Git. And I wanted to be able to drive any kind of operations in my cluster through a Git commit. So it's somehow similar to how OpenFaaS Cloud works, but instead of applying the Git flow only to functions, I'm applying this Git flow to the whole cluster. And I'm gonna show you a little the project. Of course, just running the OpenFaaS Helm chart on a Kubernetes cluster, that doesn't make OpenFaaS production ready. You still need authentication, you still need HTTPS, network policies, secrets, encrypted secrets, and so on. So this is what I'm trying to do with this repository. I'm having an OpenFaaS Helm chart that I modified and added some stuff. For example, I've replaced the fastNetIs controller with the new CRD operator. Why I did that? Because I want to specify my function definition inside Git, and I want them to be applied on the cluster. I don't want to use the FAS CLI or kubectl apply or Helm install or Helm upgrade. I want to replace all these CLI tools with just a Git commit. So I'm using Flux, which is an operator for the whole cluster. Like our OpenFaaS operator, it's only targeting the function definitions. Flux is targeting any kind of definition that Kubernetes accepts and knows. So this is how I can define my OpenFaaS chart. I've set here some things like I want 3 queue worker replicas. I've disabled the auto scaling that we are now doing with Alert Manager because in here in these repositories I'm using HPA v2 and I'm scaling the functions based on CPU, memory, and other stuff Kubernetes knows. And so I'm deploying the OpenFaaS Helm chart, but also I'm using the Binami Seal Secret controller, Heptio Contour as my ingress controller, and Chat Manager from Jetstack to get HTTPS with Let's Encrypt. And I want to show you this this image. So when you commit to Git, Flux runs inside your cluster. It will detect that your cluster state changed in Git compared to what you're running on Kubernetes, and it will apply for example, the Helm custom resources, and there is another operator, Helm operator, that takes these resources and tells Stealer what to do. For example, if you want to upgrade some OpenFaaS component, you'll just change here in the YAML, I don't know, the version of Prometheus, you do a git commit, and afterwards, everything is taken care for you. After that commit, you'll end up in production with a new Prometheus version. The same applies to seal secrets. So how seal secrets works, you deploy seal secrets with Flux. The seal secrets controller creates an encryption key. You can get the public key and you can put that public key in Git. It's no problem. Everybody can encrypt your secrets, but no one can decrypt them except your Kubernetes cluster. So this is a public repo. I'm having here all my secrets, but they are not Kubernetes secrets. They are sealed secrets. So they are encrypted. Once Flux pulls the sealed secrets of the GitHub, it will send them inside Kubernetes. Then the Bitami seal secrets controller will take the secret, will decrypt it, and attach that secret, for example, to a function, or in my case, what I'm doing here, I'm creating the OpenFaaS credentials. So if you don't know, the gateway recently got basic auth enabled. So the gateway has by default authentication. All you need to do is provide that username and password to the function. And I'm using seal secrets to do that, so I can keep in Git my authentication credentials and keep them safe. Another thing that I'm doing, I'm setting up Heptio Contour. That's an Envoy operator. It's an ingress controller, and for that ingress controller, I'm setting a certificate with Let's Encrypt, and also the certificate is stored in Git. Not the actual certificate, but the intention to have a certificate. I can actually show you how this looks like. Maybe you've never seen it. But this is how a certificate looks like. I'm creating an issuer, and I'm telling, okay, for my email, I want a certificate from the Let's Encrypt production API to be issued for me. And a chat manager who is doing all this operation with Let's Encrypt will store the certificate in a secret inside your cluster. So what happens, for example, if you delete your cluster or if you lose it by mistake? All you need to do is reinstall Flux on a new cluster, point it to this Git repository, and you'll have everything like it was before. Your OpenFaaS services will be deployed. Your functions will be deployed because your functions are in here expressed as a Kubernetes API object. For example, this is how functions looks like. Can mount secrets, of course, and everything else. So once you create a new cluster or you recover your cluster, but there's nothing in there, when you trigger the first thing, everything will run again. You have your functions, a new certificate will be issued for the same URL. All the secrets will be decrypted if you have a backup of your private key, and I'm showing in the README how you can actually do that. All you need to do to restore an OpenFaaS cluster will be to have a backup of a single file that's the seal secret private key. And it's not limited to that. I have more examples here. For example, how you can create cron jobs and execute functions on a schedule. Also, these cron jobs definitions are kept in Git. You can change them and they will be applied. You can have network policies, and here is an example of a network policy. I want a function to not be able to call directly another function, and I don't want any kind of functions to call into my gateway or into Prometheus or any other stuff outside the OpenFN namespace. So with network policies, I can create a virtual environment for my functions, and they are totally isolated from the rest of the cluster. So it's safe to run untrusted workloads in them. Yeah, and the disaster recovery is just you have to back up your CLC.
Can you show us one of the secrets that you have that's in basically in text? I think this is really cool.
Okay, so this is how.
So that secret's used for the basic authentication, right?
Yes. So this is I see my user. So if I go here, I have my URL, HTTPS. I've changed my password recently. Okay, it works. And one last thing I want to show you. Now, since we have an operator that is native to Kubernetes, I was thinking, okay, how can I extend this operator easily, right? One way would be to do a pull request, modify the operator, extend it with, I don't know, cron jobs, for example. Another idea would be to create a function that talks to the Kubernetes API. For example, I've made the function an info function, but not as node function, but a Kubernetes info function. For example, my function lists all the namespaces and counts the pods, deployment, and services for each namespace I'm running into, and some other stuff.
Could you do this with FaaSneties? I guess you probably could, right?
You could do this with FaaSneties. You cannot keep your cluster state in a Git repo with FaaSneties, because FaaSneties has no doesn't apply definitions. It's just
you could
just an API.
Yeah, you could use the deploy. Probably that's what we've done in the cloud. So this is using technologies that Stefan works on every day. Do you want to say a few words about what Flux does and some of the other bits you've used?
Yeah, so Flux is it's an operator that synchronizes your desired state of your cluster from a Git repo to your actual cluster. And it can detect drifts. If your cluster, I don't know, drifts away from the desired state, it will reapply the state every time from a Git repo. And it's not limited in any way on what you can put inside your repo. As long as the Kubernetes API understands that object, Flux will be able to keep that object state in sync. Be it an ingress controller, a secret, or a CRD like the OpenFaaS functions. Another component to Flux that we are working now recently is the Flux Helm operator that applies Helm releases inside your cluster. So instead of using the Helm CLI and I don't know some CI tool, you can rely on your cluster to actually be able to sync all this stuff. Yeah, other projects that I've used are Dynamic Secret Controller and Contour and Chat Manager and so on. All these technologies are open source and are pretty used on Kubernetes.
Thanks for the demo. I think we could have a call just going into this. I know you've done so much work on it. We've done a bit of work together on this. Looking forward to seeing the blog post published and getting some of this work put back into the main OpenFaaS, like maybe some documentation on the SILT secrets. So does anyone have any questions for Stefan? We've got a couple of minutes left, and then I wanted Lucas to tell us a bit about what we've done with secrets. That isn't a demo, so it'll be quite short. Okay, so
Sorry, have question about requirements. So, how do you initially deploy this system?
So you have a Git repo with everything inside.
Mhm.
You install with Flux on your cluster. It's a Helm chart. And afterwards, you go to settings, deploy keys, and you add the Flux deploy key inside your Git repo. And that's it. Or if you are not using GitHub, Flux issues SSH key that you can use that key to put in GitLab or whatever you want. You can actually run a pure Git server. It doesn't matter. As long as it's Git, it knows how to talk to it through SSH, and that's secure.
But previously, you need to create infrastructure for all things.
So yeah, you need to build your cluster out of definitions. I don't know, using Docker for Mac or something like that to build your cluster locally. You decide on how your production cluster should look. And afterwards, you install Flux on your GKE cluster or whatever other Kubernetes you have out there.
Mm-hmm. Thank you.
Okay. The idea is you have so many CLIs right now in the Kubernetes space. Every controller out there has its own CLI, and it's very hard to learn every CLI, make bash scripts to, make them smaller and so on. So instead of doing all that, you just keep YAMLs in your repositories and you drive operations in your production cluster with a Git flow. Like, for example, you can protect the master branch and only accept pull requests, and your SRE team will validate that pull request, that what change you want to do in production is okay. So it has audit. Any change is a Git commit. It has a history, so you actually know what's going on inside your cluster by looking at a Git history commit. And
So
blame others.
I think we should do another session on this, Stefan, and dig into it a bit deeper. It seems like we've got some more interest. And maybe Bernd could invite some of his team as well. I think they'll be interested in knowing more about Flux. I've shared a tweet about everyone's demos. So check it out, see if anybody's got any questions from the community. Also share the link to your blog post for this have repo, so you can kick the tires. Sensitive to time though. Just want to say, mute everyone. Okay, just going to say, Lucas, can you tell us what we were doing with secrets and why before everyone drops off? And I've muted everyone, so there you go.
Okay. I was going to try and share my screen, but I'm not sure I know how to. Oh, that button. So if you've been using Kubernetes, you may or may not be watching the bugs. And one that I reported recently is this one here, which we closed actually. The core of it boils down to what we're doing with secrets. We were originally trying to mount all your secrets at /run/secrets. And in Kubernetes, for reasons unknown at this point, but I think it's related to RBAC, it sometimes tries to mount things into that folder at the same time. And what we were doing was creating something that was read-only, and then this throws an error that looks something like this about a read-only file system. To fix this, one of the things that we did is decided to move stuff. In particular, secrets are no longer going to be mounted in this typical location, but in now something unique to OpenFaaS. And this hopefully guarantees that we don't conflict with other systems, whether that's Kubernetes or Swarm or whatever the future brings us. This var OpenFaaS secrets is where you should find all your secret files going forward. And this is both Kubernetes and Swarm. Part of the reason we chose to do this is to ensure that functions are written as functions, not functions for Swarm, functions for Kubernetes or different providers. And so when a function author is writing their functions, they just say, hey, I need a secret. They specify it, and it deploys in all of these environments. So if you're using Swarm for testing and then Kubernetes for deployment and production, this will continue to work. But what this does mean, because we moved everything, is if you have a function using secrets right now, that it's probably going to break. Not probably, but will break, in fact, because it's going to be looking, most likely you have something that looks like this in one of your secrets, or sorry, inside one of your functions, where you read a file at some location, and all of those locations will need to be updated to the new values. So /var/OpenFaaS/secrets. And I think that covers the core of the change and what everyone needs to be aware of.
Yeah, I would advise to modify your functions to search in both locations, deploy your functions with the old FaaS natives or Swarm operator, and afterwards upgrade. So
Yeah,
there is no downtime if you do this, but you need to do it in 2 stages.
if you want to belt and braces, you need to do this. Bernd, I don't know what way you use OpenFaaS in Dispatch at the moment, but you may want to do something depending on whether you use this. It doesn't affect your image pool secrets.
Yeah, no, we're managing secrets separately, just passing them in as function arguments at runtime. So it shouldn't affect us.
It's good to know. Okay. So we need to do a bit of sort of swarming around this, update all of the documentation in PRs, update all of any blog posts, anything like that makes mention of this. And just be ready if people come and they have a problem to respond to it, point to the right place. This isn't released yet in our charts and YAML files, but it is merged in FaaSnetty's OpenFaaS operator. And I think we're trying to get it ready in Docker Swarm as well. Okay, thank you everyone for staying on a little bit later. Have a great weekend. It's a national holiday on Monday for some people. I'll be in the US for a few weeks. So if you're trying to get hold of me at regular time, I'll be 8 hours behind normal, but I'll try and get in touch with you. All right. Bye-bye.
I'll see you in US.
Yes.
All right. Have a good weekend.
Bye-bye.
Thanks, guys.
Bye.
Thanks.